A major goal of physical chemistry is to use our mathematical problem-solving skills to gain physical insights. Homework problem 39 for the 6th edition, 32 for the 5th edition, is a great example of this. Okay, we're asked to derive the relationship between our van der Waals parameters A and B to those of our B and C virial coefficients, and we're given a hint that we need to use this expansion. We're also given the hint that we want it in powers of 1 over V molar, where V molar is simply our volume divided by N, our number of moles. So our first approach to this problem is to make sure we're aware of the appropriate equations of state we want to use. Our top one there is our virial equation of state, equation 1.25 in your book. Our second one there is our van der Waals equation of state with pressure isolated on the left-hand side of the equation, so that we could choose to set these two equal to each other if we wanted to. What we also want to remember is that we were asked to get this expansion in terms of 1 over V molar. So we can rewrite our virial expression that way. Every time we see a V and an N separated, bringing them into just a V molar term in that simplification. Similarly, our van der Waals expression simplifies in terms of V molar to what we see here. We know we had this math hint to use this expansion. The question is, in our van der Waals equation as written, how do we use this math hint? Do we see this type of term there? Well, maybe not exactly that term, but something similar. Okay, and this is definitely the biggest leap we need to make for this problem. We need to see that this isn't quite in the form we wanted in order to use our expansion. In order to do that, we need to go ahead and rewrite. We're allowed to do this mathematically. That's an algebraic manipulation there, but it's one that we maybe wouldn't have thought to do unless we had been given that hint. Okay, so now we have our previous form of van der Waals equation in V molar and our new term. We can go ahead and maybe rewrite that even more clearly to see that now this has gotten us ready to apply this expansion that we were asked to use. We can use this type of expansion so long as B over V molar is much, much less than 1. Let's go ahead and do that. We replace this term here with the expansion. Okay, of course that would keep going. I kept it up to the third order terms there so we can see what that looks like. That's more than we need for our virial expression in terms of B and C coefficients. Once again, we want to remember not to forget that we have this trailing term outside of our parentheses that was there all along. But now we want to go ahead and bring this inside the parentheses. In order to do that, we need to realize that everything in the parentheses is being multiplied by RT over V molar. When we bring that inside, we have to do so as shown here. Right? Rearranging this so that it's maybe a little easier to see in terms of our ascending powers of 1 over V molar. We have B minus A over RT all multiplying our 1 over V molar term, and a B squared times our 1 over V molar squared term. If we compare to our starting virial expression, what we notice there is that our Term here corresponds to B. Term here corresponds to C. So our answer for this derivation is the expression shown here.